Hello, everyone. I'm picking up from the notes from the other day. I'm going to post those videos, and then I'm going to probably post the answers to the book work that's due tomorrow. You should all be practicing with Khan Academy. However, I saw that 2 out of 10 in ninth period um, actually watched the video. So people got some work to do. I know a couple people emailed me yesterday about the problems on Khan, the 4 problems, the practice problems being somewhat difficult. Well, that's the point of that is you watch the video. You then watch the videos that I posted. If you need help, it's going to be on all the notes. I'm going to go over a really good one here that involves the disc method still, and then I'm going to also go over the washer method, although that's going to be up and coming. So again, lots of resources. Most of it's just video and kind of working through the problems. The idea, the biggest thing that I can say is that you are rotating a rectangle around a line, which will give you a cylinder. Remember that a cylinder has a radius and a height, and the radius is always measured from where you're rotating from. So it's always measured from the axis of rotation. All right. Case in point, when I rotate these things, I like to talk about writing in the little rotation symbol right there so I know that I'm rotating around y equals 1. Okay, so I redrew the problem here for you. We'll see how this works, and hopefully it'll be pretty cool. So anyway, here's the deal. We're going to draw a slice because that's what we're doing. All right, my slice, however, I'm going to draw this piece here. And that is my slice that goes from the x-axis all the way to the very almost top of y equals 2 minus x squared. So if I revolve that around the x-axis, that's going to give us way too much. So we got to think a little bit. I have a potential radius of being the function 2 minus x squared. However, this is not going to work because I only want this piece here and here. So let's think about this in terms of vertical line segments. From here to here is some y value that is modeled by that curve, and I know from here to here is 1. So how do I find if the distance from here to here is 2 minus x squared and the distance from here to here is 1? How do I find the little red guy here that I want? Well, I'm going to take 2 minus x squared and I'm going to subtract 1 from it. Okay, so there is my radius. My slice is going to be a cylinder, like we said in earlier lessons. Pi r squared h. The pi is the pi. R is going to be, well, 2 minus 1 is 1 minus x squared squared. And then the height of my cylinder, that might throw some of you who have not done anything quite yet. If I rotate from this aspect, this is the kind of shape I'm going to get. All right, what I'm looking at, however, is turning this on its side. And basically that little height right there of the cylinder is delta x. And then I'm going to have my radius here. And that's everything that we need. And now if I want the total volume, I'm going to integrate from some x to some other x of 1 minus x squared squared. Well, 1 minus x squared squared, I'm just going to distribute that out. There's no reason to try anything fancy integration-wise here. And that's what I'm going to be looking at. And now I just got to figure out, when does 2 minus x squared equal 1? Again, not too bad there. 2 minus x squared will equal 1 when x squared is equal to 1. So x is going to be plus or minus 1. Okay, so that means right here, negative 1, right here, 1. And if I work from negative 1 to 1, I have the subtraction of the function. So that's going from the x-axis all the way up to here yet again. And then from here to here, that's out. So I'm just basically adding up the volumes of all of those slices being rotated. So I'll try to draw another one here to let you in on what I'm talking about. So I'm drawing a little bit bigger, but the idea is that we're adding up all of those pieces as we go. And I don't know if it's going to work again, but there we go. so on and so forth. All right, so let's actually do it. What did you take the derivative of to get 1? That would be x. So I'm going to have an x. I'm going to have minus 2/3 x cubed. And I'm going to have a 1/5 x to the 5th from negative 1 to 1. So I'm going to have to do some arithmetic here, a little fundamental theorem action. Let's see, I'm going to have 1 minus 2/3 plus a 5th. And then I'm going to have minus, let's see, negative 1. Negative 1 cubed is negative, so that's another plus 2/3. And then negative 1 to the 5th is also negative, so that's minus a 5th. Double set of parentheses there. I'm going to have my pi. Oh, let's see. 1 minus 2/3 plus 1/5 plus 1 minus 2/3 plus a 5th. And yeah, I think we're looking pretty good here. I got a 2. I've got minus 4/3 and I've got 2/5. So we can do a little quick arithmetic here. That it's going to be 15 for the common denominator. 15 times 2 is 30. It's going to be minus 20 and then plus 6, I do believe, which is going to give me 30 minus 20 is 10 plus 6, 16/15 pi. And that's going to be units cubed. Hopefully that matches up with what we had on classroom. That's not the answer one, but we can pull that up real quick. Hopefully you'll not lose faith in me quite yet. Come on, buddy. Come on, internet. Hopefully all are doing well. We're getting a little bit bored here, but at the same time, my wife and I both still working out, trying to do some home workout stuff, which has actually been kind of entertaining. And yeah, lots of movies, lots of books. Good times. Sophie Jane, say hello to my class. Yeah, there's a bored 7-year-old right there. Maybe. Well, anyway, I guess I could probably end the video because you guys don't need to necessarily say this or see this. Maybe. The video will never end. Oh, there it is. Okay, signing off. I'll put some more stuff up here in a second.